Example number 4. Solve the following differential equation using Laplace transform. D squared y over dt squared plus 3dy over dt plus 9y is equals to 0, given that when t is equals to 0, y is equals to 3 and dy over dt is equals to 0, isn't it? So the first thing we do, we write this in a form that we can substitute in Laplace transforms, isn't it? So we know very well that we are differentiating y with respect to t in this differential equation, isn't it? So it means y is a function of t, isn't it? So it means when t is 0, where there is t, if you put 0, what is y, isn't it? So y, when t is 0, we've been told is what? Is 3. Y is 3 when t is 0. So where there is t, if you put 0, y is equals to 3. Are we together? You join the two, then you go to the next one. If you differentiate this, you'll get y prime to be y prime of t, isn't it? Meaning when it is 0, where there is t, if you put 0, the first derivative of y, dy over dt is what? Is 0, isn't it? Meaning when it is 0, dy over dt is 0. So these given boundary conditions, you've now transformed them into the form that can be substituted in Laplace, isn't it? So from there you now start, what is the Laplace transform of the first derivative? You are differentiating y with respect to t. So what is the Laplace transform of dy over dt? You know you are getting s Laplace transform of y, isn't it? Then it was minus y of 0, isn't it? So you are getting s Laplace of y minus y of 0. Then after that, you substitute, isn't it? So that is s Laplace transform of y minus y of 0. What is y of 0? Y of 0 is 3. Meaning where there is y of 0, you substitute it value 3. So it is s Laplace transform of y minus 3. You are done with that, isn't it? Then you go to the next term. What is the Laplace transform of d squared y over dt squared? You pick it from here, isn't it? Meaning you multiply this by s, isn't it? So s times s squared Laplace transform of y minus s times that, s of y, then it is now minus y prime of 0, isn't it? You add that final term which has added, isn't it? We saw how it was coming about, isn't it? Yes. Are we together? Then now start substituting. That is going to be s squared Laplace transform of y minus s y of 0. What is y of 0? 3. So s times 3 is 3s. Then minus y prime of 0. What is y prime of 0? 0. Meaning it is minus 0. So just remain with that, isn't it? So the next thing, after we found the Laplace transform of the second order derivative and the Laplace transform of that first order, we now just introduce Laplace in the entire equation, then we substitute, isn't it? Yes. So introduce Laplace on both sides of the equation. Here we will have Laplace transform of d squared y over dt squared, isn't it? Then it is plus 3 Laplace transform of dy over dt, isn't it? Then it is plus 9 Laplace transform of what? Of y. 9 is factorized outside, goes to the constant, isn't it? You must multiply Laplace on every term, isn't it? Are we together? Laplace of this, Laplace of this, Laplace. 3 is a constant, you put outside Laplace of that. 9 is a constant, you put outside Laplace of y, isn't it? To be equals to Laplace of 0. But Laplace of 0 is just 0, isn't it? So from there, you start substituting. You found the Laplace transform of this to be s squared man. You substitute it, isn't it? So it is s squared Laplace transform of y minus 3s. You substituted the Laplace transform of this second derivative, isn't it? Which you found there. Then you go on, it is plus 3 into Laplace transform of this in bracket. You know you must put them in bracket to mean one thing, isn't it? Laplace transform of first derivative y over dt you found to be what? S of y minus 3, isn't it? Then it is plus 9 Laplace transform of y to be equals to 0. So you substitute everything. See, the next thing is now to open this bracket. So if you open those brackets, what do you get? You get s s squared Laplace transform of y minus 3s, then this plus 3 multiplies everything inside that bracket, isn't it? So 3 times s plus 3s Laplace transform of y. Positive 3 times negative 3, there you get negative. It multiplies everything inside the bracket, isn't it? Then it is plus 9 Laplace transform of y to be equals to 0. Are we together there? Now after that, any term without Laplace of y, because Laplace of y is what we are looking for, isn't it? We take on the other side of the equation. So it means this side of the equation will remain with s squared Laplace transform of y. This minus 3s does not have Laplace transform of y. See, it goes on the other side of the equation. See, this minus 9 does not have Laplace transform of y. See, it goes on the other side of the equation. So here we just remain with s squared Laplace transform y, and this one plus 3s Laplace transform y, and that last one plus 9 Laplace transform y to be equals to what? Negative 3s going on the other side of the equation, positive 3s, isn't it? Negative 9 going on the other side of the equation, positive 9. So have you seen, any term without Laplace transform of y, you take on the right hand side of the equation, isn't it? Then after you've now done this, you now factorize out a common factor, Laplace transform of y, isn't it? So if you factor it out, what will you remain with inside? Here you remain with s squared plus 3s plus 9. Then all these are sharing the same coefficient, Laplace transform of y, isn't it? So be equals to, on the other side we have 3s plus 9, isn't it? Then for you to get Laplace transform y, you must divide both sides of the equation with this coefficient, isn't it? Meaning we divide both sides of the equation by s squared plus 3s plus 9, isn't it? You divide both sides of the equation by s squared plus 3s plus 9. So, you know, this s squared plus 3s minus 9 will cancel out, isn't it? Then you remain with Laplace transform of, the Laplace transform of y to be equals to 3s plus 9 over s squared plus 3s plus 9. So if you look at all the standard functions we've done in Laplace, 3s plus 1 means plus 9, meaning this is a common denominator, isn't it? Meaning you will be separating it. Before you separate it, you must see if you are able to factorize this, isn't it? After you are able to factorize it, you resolve it into partial fractions, isn't it? Because this 3s plus 9 may, when you resolve to partial fraction, it will turn out to be something different, constant, if this were linear patterns, isn't it? Are we together? Meaning if this s in the numerator can even disappear at times, isn't it? When you resolve, isn't it? So here, if you look at the numerator, what do you see? A product of 9 and a sum of positive 3. If you are not able to resolve, you complete the square. You know the procedure we've been using, isn't it? We said you resolve into partial fraction, meaning you can only resolve into partial fraction if you are able to factorize this denominator. Are you able to get a product of 9 and a sum of positive 3? If you are not able to get that, then you complete the square. Are you seeing how this thing is simple? If you are not able to factorize it, you complete that square. So I think the method of the completing square is even more easier than resolving into partial fractions, isn't it? Are we together there? So can we now go to this denominator, we complete this square, then we come back and put it where it is, isn't it? Are we together? Good. So go to that denominator. This thing is not long, it's only that I'm using a time to explain certain small parts, isn't it? So here we have, this denominator is what you want to complete the square, so you go to your work with it, isn't it? So you have, in our work, we have, what do we have in our work? S squared plus 3s plus 9, this denominator, we want to complete the square, isn't it? So for you to complete the square, you must ensure that this term does not have a coefficient, isn't it? And to ensure that this term does not have a coefficient, always before you start getting the Laplace transform, meaning that coefficient was here, isn't it? You must always divide it through by this coefficient so that you end up not having the coefficient of this. Is that okay? always, when you are given a differential equation, always get rid of the coefficient which is here by dividing all through by that, isn't it? Before you start solving. Are we together? So from there, it means you will always end up with s squared not having a coefficient. You will always end up with that if you divide everything by the constant which is here before you start. Okay? Are we together there? Good. So here, what do? You remove outside, you only bracket what you want to complete is square. You want to complete the square of s squared plus 3s, isn't it? Meaning this positive 9 constant term must be outside that bracket. Is that okay? So what do? You introduce space for the constant term, isn't it? So this constant term you are adding square. Meaning if you add it here, you subtract it outside, because this is an expression, not equation. If it was equation, you are going to add it on both sides of the equation to balance the equation, isn't it? But this is not an equation, this is an expression, isn't it? Meaning if you add something here, you subtract that same thing you add to look like there's nothing you've done, isn't it? Are we together? So what are you adding? This square, this term which is square, it is a half the coefficient of this middle term, isn't it? This middle term is positive 3. So a half of positive 3 is positive 3 over. So if you had that, you mean you must subtract the same thing. This and this will go back to 0. But you are doing that to complete the square for that s, isn't it? Are we together? After doing that, it means this one is now a perfect square. And the first square term here is s, isn't it? And the next square term inside this bracket is plus 3 over. So that is why you are seeing I'm taking the sign which is here with it inside the bracket, isn't it? Because when it was negative 3, here you would have written negative 3 over 2 inside the bracket, so here you put negative 3 over 2. That sign is very important, okay? Are we together? Then outside, use the calculator. So use the calculator. Plus 9 minus in bracket positive 3 over 2 squared. What do you get if you use calculator? Plus 9 minus positive. Plus 9 minus in bracket positive 3 over 2 squared, yes. Here we have 27 over 4, isn't it? That is plus 27 over 27 over 4. Then what is the next thing you do? The next thing you do, you know it is always s squared plus what? Plus a squared. Because this is s plus something, meaning this is going to be w squared, isn't it? Meaning you look for the square root of 27 over 4 squared. You introduce square and square root for you to make sure this term is squared, isn't it? So what is square root of 27 over 4? See, you look for the square root of 27 over 4, then you put square outside, because our equations will be in the form s squared plus a squared, meaning this term 27 over 4 should be squared, isn't it? So how do you reduce it? See, you find the square root and square. See, square goes with square root. See, that's how we transform it. So what is the square root of 27 over 4? 3 root 3 over 2. Is that what you have? Square root of 27 over 4? Yes. Square you don't put. Square we want here to remain squared because we are looking for the Laplace transform. This square must remain there. Yes, so it means 27 over 4 can be written as 3 root 3 over 2. Then it is square. Meaning if you square this, you get back your 27 over 4. Because we need a squared term in Laplace transform. Are you see that? Yes. Is that understood? Good. So it means where you have s squared plus 3s plus 9, we are going to put, we've now put it, we've completed that square, isn't it? So after we've completed square, what do we have? Laplace transform of y is, Laplace transform of y is 3s plus 9 over s plus 3 over 2 squared plus 3 root 3 over 2 squared. Are we together? And you know very well that in Laplace transform, it is not always s plus a, it is always s minus a, isn't it? It is always s minus a. So how do you write that? First of all, how do you write that? It is going to be s minus negative 3 over 2, isn't it? Because it has to be s minus a. Is that okay? Then you have to separate. Each and every term must stand on its own, meaning this is the common denominator of things in the numerator, isn't it? So there you'll have what? The Laplace transform of y. This is the first part here is 3s, isn't it? So it is 3s over s minus negative 3 over 2 squared plus 3 root 3 over 2 squared, because it is supposed to be s minus a. So s plus 3 over 2 is s minus negative, meaning our a is going to be negative 3 over 2. Are you seeing that? Because it is supposed to be s minus a. So this plus 3 over 2 must be written as minus negative. Okay? So you've separated the first part, then the second part is plus 9, isn't it? It is plus 9 over s minus negative 3 over 2 squared plus 3 root 3 over 2 squared. Are we together there? Now, once you've written that, you now go back to the drawing board, isn't it? You go back to the drawing board, we want to start with this first part. First of all, you know, when you have s over, that is quotient root, means it is cos, isn't it? Positive sign between them means trigonometric sin or cos, isn't it? But when it is cos, it is s over, isn't it? Are we together? When it is sin, it is a over, isn't it? So it means this one is s is in the numerator, then there's plus between them, meaning this is cos, isn't it? So we start by going back to your problem. When you had the Laplace transform of cos at, so it was s over s squared plus a squared, isn't it? But here, we have s minus a, meaning it is a product with the exponential function, isn't it? So if it is a product with the exponential function, meaning where there is, if you leave even here to be a, so you can just say Laplace transform of exponential wt cos at, so that you don't interfere with that a, isn't it? Are we together? So it means when you add exponential wt in that formula of Laplace, it is going to be times exponential negative st. So you end up with s minus w, isn't it? Meaning where there is s here in the cos, because it is now causative times exponential wt, meaning where there is s, we put s minus w, isn't it? Are we together? Because we are going to have exponential wt times exponential negative st. So if you factorize out negative t, inside you remain with s minus w. Are you seeing that? So where we have s here, you put s minus w. Is that okay? So it is going to be what? S minus w over s minus w squared plus what? Plus a squared. Are we together there? Is that okay? So if you say this was exponential, if you interchange such that where there is w you put a, where there is w you put a, and where there is a you put w, and where there is a you put w, see, we'll still get the same thing we were getting the other time. You can use any variable anywhere. Are you getting what I'm trying to explain? Okay? So you see, here it is going to be s minus a. Is that okay? So s minus a, look at your s. What is your a? Your a is negative 3 over 2. So what does that mean? First of all, look at this. This 3 is going to be taken outside, isn't it? So if you remove this 3 outside, if first of all you leave that 3 there, if you remove this 3 outside as a constant, let me show you how to transform it. I don't know whether to, let me wrap this, isn't it? To be clear. The first thing you do there's a constant term which is going to generate here, which you add on the other part. Are you getting that? So even before doing that, before you ensure that is very possible, you can track it from there before you separate 9. Are we together? So here s minus negative 3 over 2. Negative 3 over 2, you know s is having a coefficient of 3 here. So the moment you are going to remove that negative coefficient of 3 outside, here you are going to have s plus 3 over 6. Do you know the reason why I'm putting 3 over 6? When you are going to factorize this 3 outside, you are going to have s, is it not 3 over 6, it is 9 over 2, isn't it? You put it in the numerator, isn't it? So that when you remove 3 outside, you are going to remain with s plus 3 over 2, meaning we are looking for this 3 over 2. And there's a factor of 3 here in s. I don't know whether you are getting that explanation. Let me wrap there to make it more clear. I want you to understand that. That part is where it normally brings confusion, okay? Now look at this. You have 3s, but you are going to separate the s term over this to go to exponential and cos, isn't it? Then you will separate the constant part to be a product of exponential and sine, isn't it? So before you separate that, this is what you do. A, you've already found, this is supposed to be, what is here, s plus 3 over 2. It is supposed to be s minus a squared, isn't it? So this your s minus a squared, here you have it as s plus 3 over 2 squared. So if you compare, you will see negative a is the same as positive 3 over the position where negative a is occupying, positive 3 over 2 is occupying, isn't it? So for you to get s, you divide both sides by negative, isn't it? So you end up with a is negative 3 over 2. Meaning where there is a, we are going to put negative 3 over 2. But if you look here, it is supposed to be s minus a. Here we have 3s. Are we together? So when you have s minus a, you are supposed to get s plus, you are supposed to get s plus 3 over 2. So this is what you do. In the numerator, you have 3s. Are you seeing that? So it means you multiply this by 3. Are we together? So if you multiply by 3, if you take 3 inside that bracket, this 3 times s, you get 3. Plus 3 times 3 over 2, you get 9 over 2. Are we together? Meaning in the numerator, what do you do? In the numerator, it means you are going to add plus 9 over 2. So if you add plus 9 over 2, you must subtract 9 over 2. So that this joined with this will give you the cosine part. Are you seeing what I've done? Because you know very well that from here, s plus 3 over 2, s plus 3 over 2 squared is the same as s minus a squared. You use this comparison to get the value of a to be negative 3 over 2, isn't it? Then in the numerator, you have 3s. So you imagine you put your 3 outside the bracket. So 3 times everything inside the bracket, meaning in the numerator, you're supposed to have 3s plus 9 over 2, isn't it? So it means when you add 9 over 2 in the numerator to get 3s plus 9 over 2, you must subtract that same 9 over 2 to balance the equation. Are you getting the explanation? Good. So if that is well understood, then this is now how you express it. Now look how you express it. So it means this is going to be what? This is going to be 3s plus, yes, 3s plus 9 over 2 to be the part which has s minus a, isn't it? Then the other one you join with the calculator. Plus 9 minus 9 over 2, what do you get? This plus 9 and minus 9, those are constant, remain on their own, isn't it? Are we together? Yes, so plus 9 minus 9 over 2 is? What do you get there? 9 over? 9 over? 9 over 2. Plus 9 minus 9 over 2. Only 4.5. It is 9 over 2. Good. So that is positive. Plus 9 over? Are we together? Plus 9 over 2. So after that, it is everything is over what? S plus 3 over 2 squared plus 3 root 3 over 2. Are we together? Tuko pamoja? So see, at this point we now separate the sine to be root and the first one is the cos, isn't it? So we've done the cos. For the sine we are going to do when we'll be dealing with that constant, isn't it? Because for the sine has the constant in the numerator. Are you seeing that? So what do we have here? This one is equal to what? 3s plus 9 over 2 over what? Over s plus 3 over 2 squared plus 3 root 3 over 2 squared. So have you seen you've separated the one part? The other part is plus 9 over 2 over s plus 3 over 2 squared plus 3 over 2 squared. So what is the next part? The next part is now to remove the constant outside, isn't it? See, the constant in the numerator here is 3. We now factorize outside. So if we remove 3 outside, what do we remain with in the numerator? S plus 3 over 2, which is this, what is here. Are you see? S plus 3 over what? Over s plus 3 over 2 squared plus 3 root 3 over 2 squared. Then it is plus what? Remove that constant, 9 over 2. So you remove it here. Are you getting this? So if you remove that constant 9 over 2, what do you have? 9 over 2, you will remain with 1, isn't it? 1 over s plus 3 over 2 squared plus 3 root 3 over 2 squared. So you see, this one is supposed to have s minus. If this is s minus a, this is supposed to be s minus a, isn't it? And that one is supposed to be a constant w. See, and your w is what is inside this bracket. Meaning, on top of that numerator, you are supposed to have root 3. You are supposed to have what in the numerator there? 3 root 3 over 2, isn't it? So it means here you must have 3 root 3 over 2. Then you multiply it with this reciprocal, which is 2 over 3 root 3. So it means 2 over 3 root 3 we are going to remove outside. Have you seen that? Is that okay? We are going to remove that outside. That is where I want you to pay very keen attention in what I'm doing there. Because when we are going to non-homogeneous, they are going to be much more complex, just like this, okay? So after that, move to the next step. What do you get? Here, what do you have? Before we just let us simplify everything before we get back. So simplify that, you get is equals to what? Negative 3 into s plus 3 over 2 over s plus 3 over 2 ahead. 3. Oh, the negative is not there. Where? Oh, this was equal sign. That was equal sign. 3 over 2 squared, good. Then it is plus. Now remove what you don't want. You want to remain with this in the numerator. Meaning you want to remain with this, isn't it? So you take this one outside. See there? So it is now outside, it is going to be 2, 3 root 3 over 2 times what is already outside, 9 over 2, isn't it? Because 9 over 2 is also there in the numerator, isn't it? So can you go to the calculator? 9 over 2 times this, if you remove this term outside, this times 9 over 2, what do you get? 9 over? It is 3 root 3 over? It is just root 3, isn't it? That is what I'm seeing from sides. It is just root 3. See, this cancels, this 3 cancels, where you get 3 over root 3. It is 3 root 3. It is root 3. You've confirmed, isn't it? Yeah, because that is going to be over root 3 over root 3. Root 3 goes with root 3, 3 goes with 3. The final answer you remain with there is root 3 if you multiply this by this, isn't it? Have you confirmed that? Root 3, then inside, what do we have? What do we have? 3 root 3 over s plus 3 over 2 squared ahead over 2 squared. Now look at this. Look at this. The whole of this, yeah? Oh, 3 root 3, or you left over 2. It was 3 root 2, or it must be the same as what is here, isn't it? Are we together? So what is this? You know very well that the first one here is supposed to be s minus a over s minus a squared, isn't it? Over s minus a squared plus not a w. Remember, when you were looking for the Laplace transform of exponential at, of cos at, this is where we started, of cos at, cos was quotient rule, isn't it? Meaning it was s over s plus a squared, isn't it? But now when we make a to be w, it was going to be s over s plus w squared. Are you see that? Then we went ahead, when you introduce exponential at times cos wt. Are you seeing the way I'm moving stepwise? So when you introduce exponential at, meaning it's going to be s minus a. Are you seeing that? Where there is s, you put s minus? Because exponential at, when you go and put it in Laplace, where you have exponential minus at, loss of it is the same base. If you factorize out negative, you remain with s minus a into t. Meaning where there is s, you now put s minus a. Are you seeing that? Are we together? Yes, so it means this is going to be what? It's going to be s minus a. Where there is s, you now put s minus a plus w Meaning, what are you supposed to get? Exponential AT cos WT. Meaning this one, the whole of this is exponential AT cos. Have you seen that? Then you know the second part. This second part is what? Move on. So this is what is inside this first bracket, and we have 3 outside, isn't it? Then the second part, we have root 3 outside, and what is inside the bracket? You start, when you have a constant over that, it was sine, isn't it? So it means when you had sine AT, so the Laplace transform of sine AT, what were you getting? You were getting A over S squared plus A squared. Then if you change A to be W, where there is A, you put W. Then you go to the next step, when you now introduce exponential AT sine WT. Are you seeing? So when you introduce exponential AT, meaning where there is S, you put S minus A. Are you seeing that? See, there's only S here only. So it means we are going to have W, where there is S, you put S minus A squared plus. So are you seeing how the sine AT, exponential AT sine WT looks like? Are we together? So you come and you write that one there, you have, this one is the same as what? This one is the same as W over S minus A squared plus W squared. Are we together? And what did we have this side of the equation? Laplace transform of Y, isn't it? So after getting that, what do? You take Laplace transform the other side to become Laplace inverse, isn't it? Are we together? So if you take Laplace transform the other side, it becomes Laplace inverse. Then what do you remain with here? Y. So it becomes 3 is a constant. Then Laplace inverse of what? S minus, not S minus A. It is Laplace inverse where you substitute this is what? S plus 3 over 2 over S plus 3 over 2 squared plus 3 root 3 over 2 squared, isn't it? Then it is plus root 3 is a constant. Then Laplace inverse of what? W over this, which is 3 root 3 over S plus squared plus 3 root 3 over 2 squared, isn't it? Then all those other things we've done in your rough work, isn't it? See, you have the other things we've done in rough work. What have we done in the rough work? Rough work, we found that the Laplace transform of exponential AT cos WT we did in the rough work, isn't it? And we found it was S minus A over S minus A squared plus W squared. See, that is what you substitute here. So this means we have 3, then the Laplace inverse of this gives you back that, isn't it? Meaning it is supposed to be exponential AT. What is your A? It is S minus A. So you go S plus, meaning A is minus negative 3 over 2, isn't it? So it means your A is negative 3 over 2t. So it is exponential AT, negative 3 over 2t, because it is supposed to be S minus A. But you have S plus 3 over 2, meaning it is S minus negative 3 over 2, isn't it? Are we together? Then it is cos WT, cos WT. Then you check what is your W? W squared. You go where there is W squared. Your W is what? 3 root 3 over 2t. So you substitute W, then you take cos WT. WT is 3 root 3 over 2. So have you done, you substitute the whole first part, isn't it? Are we together? Then you go to the second part, there we have plus root 3. Then you go back to your rough work, isn't it? In your rough work, what have we found from the rough work? From the rough work, we found that the Laplace inverse of exponential AT sine WT, we found it is simply W over S minus A squared plus W squared. See, that is what we found in the rough work. Are we together? So from there it means the W, it is supposed, if you have the Laplace inverse of this, you are supposed to get back the original problem, isn't it? So the original problem is supposed to be exponential AT, isn't it? Exponential AT. But what is your A in this problem? S minus A. So you go where you have S minus A. Meaning s plus 3 over 2 is s minus negative 3 over 2, isn't it? Meaning a is negative 3 over 2t. So you now have at, exponential at, isn't it? Then sine w, sine wt. What is w? W is what is this in the numerator, or what is s squared, isn't it? So what is that term? Meaning this term, oh, this was root 3 over 2, isn't it? It was over 2. So you don't forget that. Even if you forget, you will always see where the problem is and you're correct, isn't it? So after that, this w must be the same as that, isn't it? Which was there, okay? So it is same wt, and our w is 3, root 3 over 2, t. So w times t. So after that, you found why you solved the homogeneous ordinary differential equation. Are we together? Are we together?